right, up next we've got Peter, also known as PaleoLogos. What's up, man? Welcome to the stream. How you doing? What are your thoughts on tonight's debate?
Hello, how's it going? Yeah, great debate, Luca and Donny. I enjoyed it. Ultimately, I thought this was a kind of interesting debate because it came down to a fundamental disagreement over basically the two main topics that you brought up, right? Both the endogenous retroviruses and the fossils. And ultimately, there seemed to be, basically this fundamental disagreement about the nature of both of those things. And yeah, I certainly thought you both did a good job. But right now, I think I'm leaning towards kind of Donnie's idea about the Sediba, Afarensis, Habilis, Rudolfensis all being chimeric as a little bit of a rescue device.
And I thought I made this clear in the opening statement, is I demonstrate directly from the paleoanthropologists themselves, right, that every single finding and every single data point when it comes to human evolution in the field of paleoanthropology is contested and debated. The opinions from these experts are fragmented. Okay, and when I say debated, I mean hotly debated. I probably spent over the last month preparing for not only this debate, but upcoming presentations and books we have, just hours and hours and hours worth of, I literally just watched a debate between I think it was three paleoanthropologists on the status of floresiensis. And they all had different opinions. And they all admitted that the hominid, the fossil evidence, it's very fragmentary, and they're just hoping for more discoveries. Now, this is right from their mouths. And the reason why I point this out is to show that fossil evidence, okay, it's low quality, it's low confidence science. And that's why I point out that it's the genetic data that's the best way to determine and answer this question of ancestry. And it just so turns out that genetics has confirmed separate ancestry and refuted universal ancestry. We can look to the Y chromosome, we can look to linkage blocks, we could look to mitochondrial DNA, we could look to taxonomically restricted genes, and we can determine that humans are not related to any other form of life. And that's what's inherited sperm and egg. These fossils, these fragments, they are not inherited sperm and egg, and they're low quality. I don't think we should be dedicating all of our time to low quality science. We should focus on high quality science. And that's my point I'm making. Anyways, I yield.
Hey, Donnie, speaking of kind of the genetic similarity, you mentioned during the debate that modern humans are 99.9% similar to one another. And what do you do then with the fact that Neanderthals are only 99.7%, whereas modern humans are 99.9% similar to one another? So what do you do with that, since Neanderthals, genetically speaking, are outside of the range of genetic variation seen in modern humans?
Well, that's a good question. And I debated that exact question 3 times, one with Dan Stern-Cardinal, one with Walking Fish, and then one with David Neff. And for one, you said it, 99.7%, and we're all 99.999% similar. But here's the thing. And I had Dr. Rob Carter on the channel about a year ago to discuss this exact question. Neanderthals were the most inbred people group that have ever existed. Their rungs of homozygosity are massive. They're also older than us today, modern Homo sapiens, okay? Which means if they were immediate post-flood, they would already start off with a different set of biodiversity. They'd already have unique sets of biodiversity, not to mention patriarchal drive, which Dr. Rob Carter has written a ton about, where you have people who are living hundreds of years old. They would accumulate more mutations and pass on more mutations through the germ cell lines, which means the founder of Neanderthals, okay, could have started off with a whole bunch of new mutations, not to mention the environmental conditions that they lived in, these harsh, cruel environments, okay, where they were surrounded by nothing but darkness. I just watched a lecture from a paleoanthropologist who talked about these Neanderthals, every single one of their bones for the most part are found with a fracture. They had a broken bone and it healed, and they lived in horrible conditions, darkness, which means lack of certain vitamins like vitamin D. So there's a good chance, I would predict, if we looked hard enough, we would probably find mutations in very important DNA repair enzymes. And what that means is mutations can accumulate quickly in a small population, not to mention recessive mutations can come to the forefront. And guess what? They become fixed. You have rapid fixation, which means you have, as expected, differences in Neanderthal genetics. And I think that perfectly explains why they're slightly different. They're not that different, but why they're slightly different from modern humans today. That's about 2 hours worth of information in 2 minutes. So I hope.
Donny, my issue with that is that, yes, I agree with everything that you just said, but that doesn't change my argument, because I'm arguing that perhaps Neanderthals were inbred. I think we have probably pretty good evidence that they are, but why can't they be an inbred species by themselves? The fact that they're inbred doesn't mean that they can't be their own different species, because when you have a small population, as you mentioned, and you have mutations getting fixed faster, speciation can occur more rapidly.
Well, I think those are good points. John, if you could share my screen. See, the problem is...
Hang on. So, ladies and gentlemen, formal announcement of a record that has just been set. We are at 27 minutes and 22 seconds into this stream, and we are already in share screen mode. So...
Oh, I got some slides too.
Bam, here we go. Is there going to be a slide measuring contest between Donny and Peter tonight? We don't know, but it could definitely happen. Who has more slides to share? I don't know yet, but I guess we might find out. Go ahead, Donny.
I appreciate. Yeah, no, that's funny. It won't be once my wife yells downstairs the spaghetti is ready, I'm running upstairs because I'm hungry. So yeah, I don't think it can be denied anymore that Neanderthals were inbred. You know, we have their genetics, and there's really paper after paper commenting on this. Here's just one reference. Inbred Neanderthals left humans a genetic burden. Neanderthal genome included harmful mutations, 40% less reproductively fit, genetic cost of Neanderthal introgression. But the one paper from Eric Trinkhaus, which really goes into their levels of homozygosity, I believe it's here, but I've also got a bunch of screenshots, but for sake of time, I won't pull it up. So this goes into an abundance of developmental anomalies and abnormalities in Pleistocene people by Eric Trinkhaus. So why can't you consider it a different species? I mean, I feel like you're just giving the evolutionists too much leeway, playing on their terms. I mean, let's look at the genotype, as I always point out, because we can see incredible variation of phenotype just based on environment. Again, I was watching a lecture from Lee Berger himself, which he talked about the cold ecoglacial environment playing a huge role in Neanderthal adaptations, as in it was almost primarily epigenetic and environment. Okay, so you could have pretty huge variations just based on environment, but not much going on the genotype. But what we see in terms of the differences in Neanderthal genotype really does have to do with genetic degeneration, inbreeding, levels of heterozygosity going down to more levels of homozygosity, rapid fixation of deleterious mutations, harmful mutations. I mean, and as a result, the phenotype's a reflection of the genotype. You have these anomalous features popping up. But here's the thing, to call that a new species, it's like on a genotype level, if you want to call a new species being the result of rapid genetic degeneration due to isolation and inbreeding and environment, sure. But I mean, evolutionists, for their type of speciation that they want to push, you know, they would define macroevolution as change above or at the species level. So, you know, but on the genotypic level, we're seeing genetic degeneration. We're seeing loss of allelic variability. you know, and here humans have low genetic diversity. So I don't even think they have the capabilities of massive amounts of variation like animals and plants do. So, you know, it's probably up to debate. It's probably more semantical, really. I wouldn't call it a new species. You know, maybe I could see, well, no, with Neanderthals, I could show you a ton of quotes right now from paleoanthropologists. I could pull up the lecture that I was just watching from 4 months ago, where the speaker, a secular evolutionist, he said, no, Neanderthals are us. We're the same species, debate at best subspecies, but not a different species. No, I don't think that that's defensible. Not even if you're an evolutionist. Even the evolutionists agree. Neanderthals and Homo sapiens, same species. Go ahead. I said a lot there. Take your time.
Well, some evolutionists agree, but I mean, like, you could find people to claim anything. But here's my issue. It has never been proven that deleterious mutations can lead to Neanderthal morphology. You brought up in specific dark environments, and I think you were kind of going back to Rudolf Virchow's ideas, kind of a father of immunology, if I'm correct. But his thoughts about the Neanderthals were that they were people who had rickets. And one reason why he thought that is because the Neanderthal femora has a unique curvature in terms of the posterior aspect, which in fact is quite different from that seen in people with rickets, where it's to the side that the femur bends rather than posteriorly. But based off of that incorrect kind of diagnosis of rickets, Rudolf Virchow claimed that Neanderthals were people with rickets. Is that what you were saying?
No, I don't think it's as simple as that. I'm talking about how environment, inbreeding, shifts from heterozygosity to homozygosity, and the manifestation of deleterious recessive mutations can lead to rapid morphological degeneration. That's pretty well understood. We also understand the effects of reductive evolution on small inbred populations. Have a look at Floresiensis, have a look at Naledi, have a look at Luzonensis. That can result in small body size, small brain size, curved fingers. It can result in a ton of anomalies. We also know that lack
of, let's say, that those things were the result of that? That is my question. How do you know that those features are the result of those mutations?
Well, I showed a quote. I don't know if you looked at in my opening statement. I showed a quote from, I can pull it up here, where he points out. Let me see here. He points out that a lot of these pathologies, these hominids were living in a different time, different conditions, different than today. So if you have an erectus that's degenerating morphologically, it's going to be different than a modern. It's going to have different effects in phenotype than if it's a modern Homo sapiens today that's experiencing that. John, share my screen. I'll show this quote. So this one's from.
Hang on. Hang on. So the first screen share was at 27 minutes. The second one was at 34 minutes. Go ahead.
Well, I know. When people are asking for evidence, it's hard to not just screen share. So here we go. Oxnard. Here's where it actually came from. You know, evolution is like, oh, you quote mine. Well, I went and found the book, found the quote. It is remarkable that so many features similar to those normally present in great apes and Australopithecus and Paranthropus and early Homo erectus to some degree, so on and so forth, but not in modern H. sapiens, are generated in humans by growth deficits due to the absence of thyroid hormone. You know, this is just one of them, cretinism. In other words, many of the pathological features of cretinism mimic the primitive characters of evolution, making it easy to mistake pathological features for primitive characters. So listen, my point is, if you want to focus so much on low quality, low confidence data to answer the question of ancestry, go ahead. But it's based on massive amounts of imagination, inference, assumptions. Okay, that which is supposedly or assumed to be primitive or basal may actually be just the result of morphological degeneration. And if we see on a genetic level that we're dealing with a people group that is the most inbred that has ever existed on the planet, 40% less fit than modern humans, not to mention their environmental conditions, which suggest that they were low in important vitamins, including vitamin D, incredibly incredibly low in terms of just so many things based on the environment that will allow for rapid fixation of new mutations. I really don't think it's a huge stretch to say that the degeneration that we know for a fact exists in their genetics, let's say Neanderthals specifically, would not also manifest itself in the phenotype, in the physical features. I mean, to say no, to say it wouldn't, I mean, that's the stretch. Go ahead.
Hey, I have a question real quick for Donny.
Well, I think Peter wanted to, we want to be fair. Have Peter have the last word there on that one, because he's been very respectful. And then Jackson, you go.
Okay, what I'm saying is we can tell the difference between cretinism and morphology. In other words, we can look at Neanderthals and we can see when they had bone diseases, because bone diseases leave behind evidence of pathology on the bones themselves, and we can tell that. There is a difference, and we can see in the fossil record what is pathology and what is not pathology, and I think that you are equating the two a bit.
Well, Peter, can you explain to the audience the meaning of founder effects in a population?
Absolutely. A founder effect happens when a population comes from a very narrow group, a starting group of organisms, which can have some unique features as compared to kind of the rest of the ancestral population. And thus, the population which those individuals give birth to eventually becomes quite distinct and isolated from other populations.
That's right. I appreciate that. So here's the thing. It's not like, well, this individual, suffers from, cretinism, low thyroid hormone, and this guy has, arthritis, and this guy. No, it's population wide. These morphological features, these degenerative anomalous features have become fixed in the population. For example, these island dwellers like Naledi, Luzonensis, and Floresiensis. I correct myself on Naledi. Naledi is more of just an isolated people group as compared to the other two. But the other two experience the effects of reductive evolution as a result of being isolated and inbred on these islands, where eventually the population shifts towards these anomalies, these anomalous features being the norm. Like that's what makes up the population. And again, you'd have to deal with right here. I'll share my screen for the third time, John. I know, I'm sorry. This
Do you
paper
know
here.
how crazy it is, though, to claim that an entire population of people had cretinism? Like, that is a kind of absurd
I'm
claim.
not saying the entire population of people I'm just pointing out that various pathologies, okay, and then obviously morphological degeneration population-wide, especially if it's just a tiny little population, can be mistaken as primitive or basal or pre-human, when in fact it's just morphological degeneration. Okay, just saying one guy has cretinism within the population. No, we're just showing that pathology can result in typically what we see. But our model of post-Babel dispersal would say that these subpopulations, these features became fixed because of generation after generation of deleterious mutations coming to the forefront, leading to reductive evolution. Here's the thing. When you have these subpopulations, like let's say Floresiensis on an island, well, let's say you have Erectus, okay, that gets onto the island and becomes isolated, inbred, mutations come to the forefront, so on and so forth. Well, guess what? The first thing natural selection is going to deal with is brain size, because brains are energetically costly. Okay. And when you're short of food and resources, then guess what? Eventually over time, the brain is going to shrink in order to conserve energy, so that population can live in an environment where it doesn't need to consume as much food and it doesn't need to consume as much resources.
But once again, that's just called adaptation to your environment. I don't see why you have to call that.
It's reductive. It's going from a bigger brain to a smaller brain because of your environment. It's reductive evolution. It's well understood in the literature.
But it's evolution that is beneficial to the organism. Well, let me bring
It's not beneficial because these groups went extinct.
Yes,
I want you to deal with this paper.
You don't know why they went extinct, though. It is beneficial to the organism because it allows the organism to survive in an environment where they might not otherwise survive because their brain might consume too much energy.
Well, see, no, that's wrong, because here's the thing. We see it in Lenski's bacteria is they are experiencing reductive evolution. They're losing genes short term for adaptive purposes. Okay, we can apply that to Floresiensis or Naledi. Short term adaptation, reduction in brain size, results in long term degeneration. Guess what? Lenski's bacterial populations, they've all shrunk in functional genome size. And that's what you see in these hominid people groups. And I would predict, since we don't have their genetics yet, that if we did get their genetics, we would see an abundance of harmful mutations. We would see high levels of do you think a population can just go on for prolonged periods of time with massive rungs of homozygosity? Of course not. You can't just inbreed yourself into a greater population. Look at these inbred people groups today. Go ahead.
Let me bring up the example of the Neanderthals. Neanderthals follow these effects known as Bergman and Allen's rules, which kind of govern exactly how body size and limb size looks in comparison, to the latitude in which an organism lives. How is that an example of genetic degradation when Neanderthals appear to have adapted to their environment and become shorter, stockier, and more muscular?
Right. That's a good question. And I talked about that in my opening statement. The environment has allowed them. And remember, if Neanderthals were founded by an early biblical patriarch, as I pointed out earlier from your first question, they would already start with a whole bunch of new mutations. If they were earlier, closer to the flood, then again, they would start off with unique sets of biodiversity, but they'd probably have more genes for longevity. If they're closer to the flood, they probably originally have, let's say if they were Heidelbergensis, let's say, their genome has less harmful mutations, because the Neanderthals we look at today, based on these studies where they left humans a high genetic burden, they are the end stage Neanderthals. They are the Neanderthals that are the most homozygous. But if we looked at, say, the genetics of Heidelbergensis or an example of Neanderthals before what we see now, the end stage Neanderthals, we'd probably see less harmful mutations. So yeah, they go into these environments, and environment allows for rapid adaptation through epigenetic means. They're more robust, they're massive, their eyesight is great, because remember, they're still retaining probably much of their longevity genes in their early biblical patriarch that maybe they were founded from. But over time, you still lead to more and more degeneration.
I see no practical way that your view can be distinguished from speciation.
Is that your only argument, is you want to call them a different species?
No, I'm simply saying...
Is that your main contention?
No, I'm saying you are arguing that they aren't a separate species, but at the same time, you're saying that all the things which make new species in terms of Neanderthals did not make a new species. So what is the difference between speciation and genetic degradation?
Well, firstly, and that's a good question, I do want to point out for the audience sake through visual form. Okay, these are, just snippets from Smithsonian and non-Young Earth creation related sources. Our genes suggest that modern humans interbred with Neanderthals, and that's led some anthropologists to claim Homo neanderthalensis should be considered a subspecies of Homo sapiens rather than a separate species. You can read this. What does it mean to be human? So on and so forth. I mean, by the biological definition of species, we have their genes, we interbred with them, we produce fertile offspring. We are the same species. I would say it's more appropriate to refer to Neanderthal as a degenerative variation of humans. I mean, I don't know why you want to call, I see your point, but I think a lot of it is semantical, because I oftentimes point to the new species of Darwin's finches on the Galapagos Island that was, that speciated due to shifts in heterozygosity to homozygosity, new hybrid species. And they're probably interfertile with the parent population. So are we going to call that a variation of finch, a new variation, a new species? I don't know. I think it comes down to semantics, but all I can do is point out the fact that many paleoanthropologists say Neanderthals are the same species. And on a genotypic level, we know that their differences from us is mostly due to degeneration rapid fixation of new mutations.
My
and
issue is
inbreeding.
that you're
So-
once again equivocating speciation with these degenerative things. And so while you're willing to accept speciation and other things, for some reason, you seem to be kind of unequal in how you're using the term speciation, because in other animal kinds, you're willing to say that all these things that you're saying about humans led to speciation. But for some reason, when you get to humans, you immediately don't want to say that.
Well, that's because I wouldn't predict speciation from humans, because from the biblical model, God creates two human beings, Adam and Eve. That limits the amount of variation you can get. Okay, that's why we have low genetic diversity. The evolutionist has a post-hoc, ad hoc, ridiculous idea that there is this massive population bottleneck in Africa that reduced levels of heterozygosity. I mean, I've had whole debates on that, how unfeasible that is. We can get into that at a different time.
We better let some other people talk, but we can get back to this.
Well, I just want to make the point that people understand. Okay. And this is the model that I would share with people like Jensen and Carter. God created a planet full of animals, massive amounts of animals. That's why the evolutionists will oftentimes say, well, you know, there's more variation in the felid species that you would say are of the same kind. But yet you don't want to say humans and chimpanzees are related, even though there's less variation. And I typically say, yeah, because God created a planet full of animals, which means we would predict higher levels of diversity and a greater ability for variation in animals and plants, with a lower ability to vary in humans.
What did you mean by the felid species?
Well, you'd have
or did
kingdom,
you
phylum, class, order, family, genus, species. You'd have species of cats within the greater family of cats, lions,
okay,
tigers,
so you're not
cheetahs.
saying felid is a species, you're saying species of felids.
Right.
Okay.
Yeah.
Okay.
Species within the family that we would say belongs to the same created kind. So cheetahs, house cats, lions, tigers, there's more variation within those species. And yet we would say as a creationist, they belong to the same created kind. But humans and chimpanzees have less variation between them, but we would say they're not of the same created kind. Well, why is that? Isn't that inconsistent? Well, no, from our starting point, that's exactly what we would expect.
No, so you are being inconsistent here, because when we talk about diversification of felids, for an example, founder's effect, mutations, all of that, as well as, you know, possibly genetic heterozygosity, all of that can explain speciation within felids. All of those processes can work the exact same way they do in felids in humans. So why aren't you consistent then in your application that if you believe new species of felids can arise, why can't new species of humans arise? That's my question.
Okay, so it's your contention then that there are different species of humans, and you don't like my criteria for...
No, I'm just saying you're being inconsistent, because you're
I don't
saying...
think so.
Yes, you are, because you're saying felids can speciate. You believe that felids have speciated.
Guys, Jackson is trying to speak for quite
Let's
some
let somebody
time
else
now.
go.
No, well, wait. No, I want to say one thing, because it comes down to semantics. The evolutionists want to say that these different cat variations are different species. Sometimes I think we're giving them too much credit. We say the word species, we say the word speciation because we're talking to an evolutionist. And I know for myself, I read a lot of their literature and I want to talk in their language so they understand. But when it comes down to it, what are we really dealing with? New species or just a variation within the same kind? Because again, when we look to the genotype, we are not seeing anything that is going to help the type of speciation that evolutionists want to be true based on large scale evolution. Okay. So here's the thing. If tigers and lions and cheetahs and whatever, if they can interbreed, they're an interbreeding population, it's probably better just to say variation in the same kind. Neanderthals and humans, we have their genetics. We interbred with them. Okay. Many paleoanthropologists say Neanderthals are us. We are the same species, even according to them. So it's a variation of humans, but we actually understand that they are a variation due to degeneration, due to founder effects, due to environmental adaptation and morphological degeneration. I mean, you can call them a different species, but I think that's given the evolutionists
No,
way too much.
my point right now is not to
All
argue.
right. Listen, I think there's going to be like screen sharing that's going to happen again if we don't stop this. So,
my name is Johnny Joyce, and I'm your host and facilitator this evening. Thank you for attending tonight's lecture. A short introduction of our speaker is in order. He grew up in Chicago, earned degrees in paleontology and history from Augustana College, and traveled to Wyoming while in his early 20s. He currently works for the Wyoming Department of Environmental Quality, Land Quality Division, and is also an adjunct professor of anthropology at Sheridan College. He is a board-certified professional geologist and has two hobbies: building computers and researching human origins. Ladies and gentlemen, B.J. Christensen.
Homo sapiens Neanderthalensis. Until fairly recently, Neanderthals were considered to be a separate species from humanity. They are not. They are us. Long, long ago, people thought we came from Neanderthals. But by and large, what we're finding out in the last 10 years is that they are us, but modified for a cold climate.
I hope you enjoyed this video. Please make sure to hit that like button, it really does help, and subscribe if you enjoyed the content and want to see more. This is Matt Man. Until next time.